Good morning, students. Welcome to Brilliant Public School. The topic for today's discussion is Concepts of Straight Lines for class 11th. Let us see what is the prerequisite knowledge required for this topic. In your previous class, you have studied concepts of coordinate geometry, distance formula, standard form of the line, section formula, and area of triangle when its three vertices are known. In this chapter straight lines, we are going to go ahead with slope of line, forms of line, general form to write slope of line, types of general forms, distance of a point from a line, and distance between two parallel lines. Now let us recall the distance formula which we have studied in class 10th. Distance formula is used to determine the distance between 2 points. That is, consider point P and Q with the coordinates x1, y1 and x2, y2 respectively. Now, we have already studied that the distance formula between these 2 points is given by d is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Further, let us see what is slope of a line. The angle theta made by the line L with the positive direction of x-axis and measured anti-clockwise is called as slope or inclination. In the figure, you can see the line L which is making an angle theta with the positive direction of x-axis. Now, slope of a line when 2 points are known. If we know the 2 points, that is P and Q, with the respective coordinates x1, y1 and x2, y2, we can find the slope of the line by considering an arbitrary point x, y, and the linear equation in x, y can be written in the form y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1, where y2 minus y1 upon x2 minus x1 is slope of that line. If the two lines are parallel, then the slope of the lines are equal. In the figure, consider two non-vertical lines and line L1 is parallel to line M2. So, we can conclude that their slopes M1 and M2 are equal. Conversely, if I know that slope of two lines is equal, that is M1 is equals to M2, then I can conclude that the two lines are parallel to each other. Next, if the two lines are perpendicular, two non-vertical lines are perpendicular if and only if product of their slopes is minus 1. That is, if L1 is perpendicular to L2, then M1 into M2 is equals to minus 1. Or if M1 into M2 is minus 1, then L1 is perpendicular to L2. That is, we can say that if the lines are perpendicular, the slopes are negative reciprocals of each other. Now let us come to the point of angle between the two lines. Consider line L1 with slope M1 which is tan theta 1 and L2 that is tan theta 2. From the figure you can very clearly see that tan alpha can be written as tan theta 1 minus theta 2 using the exterior angle theorem. Using the formula of tan A minus B, I get tan theta 1 minus tan theta 2 upon 1 plus tan theta 1 tan theta 2, that is m1 minus m2 upon 1 plus m1 m2. Now let us come to different forms of line. The first form is point slope form. This form is used to find the general equation when one point on the line an angle is given. So from the diagram it is very clear. I have the knowledge of one point, that is x1 y1, and I take an arbitrary point xy on the line. So I can get the equation of line. If m is the slope of the line, the equation of this line is given by y minus y1 is equals to m into x minus x1, where m is slope of line and x1 y1 is any given point on the line. Now next form of equation is when we have the knowledge of 2 points, and hence it is called as 2-point form. I have 2 points, P1 that is x1 y1 and P2 that is x2 y2, and I took an arbitrary point x and y on the line. Now the linear equation in x and y can be written in the form y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1. Now the next form is slope-intercept form. In this case, I know slope of the line and I know one intercept on any of the axes. So here slope-intercept form is given as y is equals to mx plus b, where m is the slope and b is the y-intercept. Now next form is intercept form. So here we know only the intercepts on the respective x-axis and y-axis. Suppose the line makes x-intercept A and y-intercept B on the axis, so that the line meets at x0 and y0. So by 2-point form, the equation of the line is x upon A plus y upon B is equals to 1. This equation x upon a plus y upon b, where a and b are the intercepts on x and y axis respectively, is called as intercept form. Next form of the line is normal form. Now let us consider non-vertical line, where we know the length of the perpendicular P from the origin to the line, angle alpha which the normal makes with the x-axis in the positive direction. The slope of the line will be m is equals to tan alpha, that is sin alpha upon cos alpha. The normal form of the equation is given by x cos alpha plus y sin alpha is equals to p, where you can very clearly see in the diagram that p is the perpendicular distance of the line from the origin and alpha is the angle made by the normal to the given line. Now let us recapitulate that which all forms of equations of line we have discussed. Slope-intercept form, y is equals to mx plus b, where m is slope and b is the y-intercept. Point slope form, where we have knowledge of one point and slope, that is y minus y1 is equals to m x minus x1. Standard form of equation of line, you know it very well, that is ax plus by is equals to c. Intercept form is x upon a plus y upon b is equals to 1, where a and b are the intercepts on x and y axis respectively. Let us recall the things which you have studied in 10th. A vertical line, the equation of that line is given as x is equals to a, and horizontal line which is y is equals to b. So keep practicing, children. Solve questions based on these concepts. Learn the formulas very well. Thank you and have a nice day.